All right, here's a quick summary of what we covered on Tuesday, February 28th. First, we reviewed what Miss Mitchell, your substitute teacher, covered with you last class. She covered section 7.1 on similarity. And what this means conceptually when two objects are similar is that they have the same shape though different sizes. The definition of two shapes which are similar says that they are similar if all corresponding angles are congruent, while all corresponding sides are proportional. Now, what's a proportion? Proportion means equal ratios, like the ratio of A to B and the ratio of C to D. If they're equal, then they are proportional. As an example, can we prove whether or not these triangles are similar? First, we'll start with part one, corresponding angles. Well, J and P are both 90 degrees, so they're congruent. Using the triangle sum theorem, which says the three angles add up to 180, we know that 90 plus 23, if we subtract that from 180, we'll get the third angle, which is 67. So we can determine that the missing angles were 23 and 67. And so we can see that angle M and angle T are both 23 degrees, so they're congruent. And angle R and angle E, they're both 67 degrees, so they're congruent. So we've satisfied requirement number one, the corresponding angles are all congruent. Now we need to check to see if the corresponding sides are proportional. So we'll take RJ, the shortest side. Who does it correspond to? The shortest side, EP. So RJ to EP. All right, and then from the blue triangle, the middle side, MJ, that corresponds to PT, TP. And the hypotenuse, which is MR, corresponds to the hypotenuse ET. So these are the three corresponding ratios of sides, or the three ratios of corresponding sides. And when we fill in the numbers, they are all equal to each other. So requirement number two is met. Corresponding sides are proportional. Therefore, these shapes are definitely similar. The similarity statement actually names them. Triangle MRJ is similar to, and you've got to name the green one in the same corresponding order. So MRJ started by the 23-degree angle, went to 67 and to 90. So we have to start at the 23-degree angle and go to 67 to 90, TEP. And the similarity ratio is either 2/3 or 3/2. It can be either one. The similarity ratio tells you how many times you have to multiply the lengths by to get the new one. So if we're going from the blue one to the green one, we're getting bigger. The similarity ratio would be 3/2 or times 1.5. But if we said we're going from the green triangle to the blue one, then we're getting smaller. And so in that case, the similarity ratio would be 2/3 because we are 2/3 as big as we used to be, which makes us smaller. All right, well, that's a review of section 7.1. So what's the new stuff in section 7.3? Because we're skipping section 2 and going straight to section 3. Section 3 are shortcuts for proving that triangles are similar. And there were three of them. The AA similarity theorem, which says if two triangles have two pairs of congruent angles, then they're similar. The SSS, which says if three pairs of corresponding sides are proportional, then the triangles are similar. And the SAS, which says if two pairs of corresponding sides are proportional and the angles in between those sides, the included angles, are congruent, then the shapes are similar. So here's our first example. If we're given this information, we know that angle T is congruent to angle P. And if this is perpendicular, we know that this angle and this angle are both congruent 90-degree angles. And we need three letters to describe angle QTJ, which is the one on the left, and angle QJR, which is the one on the right. So that's it. Since we have two pairs of congruent angles, the triangles are similar. And if you call this one TJQ, T to the right angle to Q, then we start P to the right angle to R, PJR. Next example. Are these triangles similar? So notice we've got side lengths and we've got some congruent angles, so we're probably going to use the SAS. So congruent angles are NMP and RMQ, and the sides in which these angles are included are the two blue ones and the two yellow ones. So corresponding ratios, we'll do the short blue one to the short yellow one, 4:6. Is that the same as the long blue to the long yellow, which is 8 to 12. And those are equal to each other, so we're done. These triangles are similar by the SAS similarity theorem. One more example. How about these triangles? We don't know anything about angles. We're probably going to use the SSS in the end, and we have to check corresponding side ratios. So DF is the shortest side. That corresponds to the shortest side, JL. DE is the middle side of 6, 8, and 10, so that corresponds to the middle number of these, which is 16, which is KJ. And then the longest side of the blue one divided by the longest side of the red one. Are they all the same? They're all equal to 0.5. So, by the SSS similarity theorem, triangle FED is similar to triangle LKJ. And if you name this one FED, we started where the shortest and the longest side met. So the shortest and the longest side, we have to start at L. And then from the F to the E, we went along the longest side. So from L, we're going to go along the longest side to K, L, K, J. All right, I hope those quick examples helped a little bit. Do the practice assignment on class on Thursday. The very first thing we're going to do is a little practice, and then we're going to go over the answers to the assignments you've practiced for section 1 and 3, and then we'll take the quiz.